Hi, welcome to my new video about Apache Spark structure streaming integration with Apache Kafka schema registry. And in this demo, I will show you an open source project that you can use to plug your structure streaming pipelines to schema registry. And this project is called Abris. So on my screen, I have my consumer. I have a consumer that will connect to schema registry with the help of Abris. So to connect to schema registry is very straightforward. You define what type of reader you want. So you can see that we have a sample Avro reader or a Confluent Avro reader that connects to Confluent schema registry. Later, I'm defining all the configuration I want for my reader, and as we could use here, for example, from JSON method. So from JSON, we define exactly like from JSON. We define the schema that will be resolved thanks to the Abris project. And the thing to know, at least about this code, is that the from Avro comes from Abris and not from Apache Avro Spark module. And that's quite important because otherwise we couldn't use this to Avro config and from Avro config for the readers. So now I will quickly show you the producers. So the configuration is very similar, except that we are using the to keyword in the configuration, in the Abris configuration. So as previously we defined that we want to work with Confluent schema registry with the last versions, with some topic that is not, and that for this specific schema we retrieve the schema for the value, and on with this URL. And to write this data, it's, as I said, also very easy because we are simply calling the to Avro with the columns we want and the schema retrieved dynamically from the Abris configuration. So in the demo, I will use this Docker Compose configuration based on Confluent Kafka distribution. Simply because it's very easily integrated with schema registry, we have nothing to do. So let me start it. So let me start now the broker. And I will also get my snippets to create the topics and the first version of the schema. So yeah, it's currently running, and maybe I can try to create the topic. And normally it should work. Yes, it worked correctly. I created the orders topic. So now I will take another snippet I prepared and I will create the schema for the orders value. And in this schema, we have an optional ID and required amount fields. So the schema was created with the version number 1. Now I will start the reader in debug mode to show you how Abris resolves the bytes, because there, as you know, in Kafka there is nothing more than an arrays of bytes that are later interpreted by the consumers. So in the demo I will show you how Abris interprets these bytes and converts to Apache Spark format. So that was only for the first microbatch, and now I will start the first writer. So the difference is that the first writer has only 2 fields, whereas the second writer will have an extra field with some tax information. So I will start it, and we should see very soon that we should see very soon some debugging breakpoints. Yes, so we have our breakpoints, and it's a sign that the microbatch executes. And now we are converting this array of bytes from Apache Kafka to Apache Spark rows. And to do that, Abris will call this private decode method, and depending on the configuration, it will either use the Confluent schema registry or simply decode Avro to Spark. So since we are working with Confluent, we will go to this method, and as you can see in this method we start by reading the schema ID from the input row. And now the thing will be interesting for us will happen here. So here, if the schema is unknown, so which is the case obviously because we are going to this get or else update function. So when the schema is unknown, we will download it from schema registry by using Apache Kafka schema registry native classes. So once we downloaded it, we will simply use this generic datum reader, which is an Apache Avro component, to convert the bytes to some result. So, and this time you can see that we don't download the schema definition anymore because it's already in this Confluent Reader cache map. So now I will make the things a bit complicated. So I will once again call the schemas API endpoint, but this time I will add an extra field that with my tags information. So we have registered a new schema now, and I will start the producer that will produce the records, the order data, having this extra tags information in the array of bytes that will be later decoded. And I will show you that the decoding steps have started just now, and that we have this schema ID equal to 2, meaning that we will once again need to download it from the schema registry in order to convert the array of bytes to Apache Spark data representation. So I will just skip this part and introduce maybe the second topic that I will present in different video. So the interesting thing is that if you observe the data that we are dealing with in our structured streaming pipeline, you will notice that despite the fact of using the new version of the schema, we still have two columns, two attributes in the record column, and also we only have two columns in the exploded version of this record column that is exploded with this expression. So that's something normal, and in the next video I will explain you why. And if you would like to know more about Avris and generally about schema registry integration with structured streaming, I invite you to the article I have wrote and linked in the description of this video. It was Bartosz Konieczny from waitingforcode.com. Thanks for watching.